nice to see everybody. I understand that Connor has been warming you up and reducing you to a jelly, so you're ready. So this is Alan Turing, as many of you know, because now he's on the 50-pound note. And we all know that he wrote a paper that we now describe as the Turing test, did amazing work during the war on breaking codes, founded the field of computer science when he was still a grad student. But he also said this in a 1951 lecture. He was talking about the long-term prospects for artificial intelligence, and he said, "It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control." And that's it. He offers no solution, no apology, just resignation. And I think we'd have to agree now with the first part, right? Once we figure out how to make AI systems that are roughly as capable as human beings, they will very quickly outstrip us. They have enormous advantages in sheer computational speed, in memory, in bandwidth, and their ability to communicate and share information with each other. So I think the period of parity with human intelligence would last possibly only a few months. But I do want to take issue with the second part of this, and I'll explain why later on. But we actually ignored this warning. There were a few echoes of it in 1965. I.J. Good, who actually worked with Turing at Bletchley Park, talked about the intelligence explosion, the idea of recursively self-improving machines that could also leave humanity far behind. Marvin Minsky, one of the founders of AI, also talked about the possibility of AI systems creating change in the world that would leave human beings with no place left to survive. But by and large, we ignored this completely. And around 2013, I started to think seriously about what happens if we succeed in the goal that we have set ourselves, which is to create exactly the kind of AI that Turing says would take control. And so I made this little imaginary email conversation where the superior alien civilization sends email to humanity@un.org saying, "Be warned, we shall arrive in 30 to 50 years' time." And how does humanity@un.org reply? Some of you already know the answer, so don't shout it out. All right, humanity says, "We're currently out of the office. We'll respond when we return." And they include a smiley face just for good measure. Right? This is the response of the world for most of the last 70-odd years since Turing gave us that warning. And what's going on right now? Right? It doesn't feel like this anymore. So everyone talks about the arrival of ChatGPT, which was November of last year. And that created, I think, universal or almost universal awareness that something was happening in AI that people should pay attention to. But it was really GPT-4, which came out on March 14th. So interestingly, that's almost 6 months. We're now almost 6 months to the day since the release of ChatGPT-4. And along with that, a group at Microsoft, a very distinguished group of scientists, had been studying GPT-4 for several months. They probably had more experience using it and exploring its capabilities than anyone else on Earth at that time. And they published a paper claiming that GPT-4 shows sparks of artificial general intelligence, the kind of AI that Turing said would take control of the world. And as a result, FLI, the Future of Life Institute at MIT, decided that we needed to wake people up to this issue. And so they wrote an open letter. They got a lot of people to sign that letter. And the letter said basically, we need to pause this kind of large-scale model training and release until we have better understanding of how to predict and control its behavior and how to regulate this kind of technology. I did sign that. My view was that the delay should actually be indefinite, that we should simply say these systems have to be predictable and controllable, otherwise we can't be developing and releasing these kinds of systems. So I think it was at that time that humanity returned to the office and read the email from the aliens, and essentially pandemonium ensued, almost as if this really was a message from the aliens. The very next day, UNESCO issued an urgent call to all of its member states, which is pretty much every country on Earth, saying, you know, all of those principles that we've been encouraging you to take on board about artificial intelligence and responsible development, stop thinking of those as recommendations and start thinking of them as laws. Write those laws now because we need them to be in place. OpenAI itself, a week later, called for governments to impose safety regulations on these types of AI systems. So that's a pretty interesting set of developments to happen within a week of an open letter that many people derided as completely ineffectual and a waste of time. A lot of other people said, well, actually, this is not just a waste of time. You are handing the AI race to China on a plate. I personally received several emails accusing me of being a traitor to my homeland. Maybe some people didn't know that I wasn't, that I'm both American and British. But anyway, 10 days later, or 11 days later, right, so China issues their AI regulations, and they are much stricter than anything that Western countries had considered. In particular, they said that these models have to output true and accurate information. If you know anything about large language models, you know that that's completely impossible, because they can't tell the difference between truth and so-called hallucinations. They output false information all the time. And so, in effect, the Chinese government was banning public-facing large language models. So since then, there have been a number of developments. Just a couple of days ago, two senators, Hawley and Blumenthal, Hawley being an extreme right-wing Republican, Blumenthal being a Democrat, they've managed to achieve an incredible degree of bipartisan consensus that we need to regulate AI and we need to do it soon. And the kinds of measures they're talking about are quite stringent measures, not quite as stringent as I would like, and we'll see why. But this is really a remarkable development. And I think if you're a politician and you look at what's going on, you can say, okay, well, there's, on the one side, uncontrollable AI that will dominate the Earth. On the other side, there's the human race. I wonder which side I should be on. Right? And if politicians are good at one thing, it's putting their finger in the wind and figuring out which side they should be on. And they all seem to be voting for the human race. So that's good. We saw Jeff Hinton resigning from Google so that he could talk about his fears of extinction. We've had emergency meetings at the White House, and of course, we have fairly soon now the United Kingdom's Global AI Safety Summit happening on November 1st. And the UK actually taking a leadership role in putting AI safety at the front of the agenda. So really amazing developments in the last 6 months or so. And oddly enough, we still haven't seen a system released that's more powerful than GPT-4. So in fact, the moratorium that was requested in the open letter has actually been respected. Okay, so here's the thing, right? This is the question that Turing asked himself. Okay, it's obvious that the reason we have power over the Earth is because of our intelligence. We are not particularly big or strong compared to many animals, but we are smart enough to be able to dictate the fate of any other species on Earth. And we have already actually ended the fate of thousands, if not millions, of species on Earth. So intelligence simply means the ability to act in such a way that you achieve your objectives. So if AI systems are more intelligent than us, and they have objectives that don't line up with theirs, whose objectives do you think will end up being the case? Ours or theirs? Well, obviously theirs. And there's no guarantee that their objectives are consistent with human existence or happiness or anything else that we might care about. And if you look at the question written that way, it almost seems, and I think this is the conclusion Turing came to, it just seems like there is no answer. So if we think about that point, right, that misalignment of objectives is the reason why things go south, right? That AI systems pursuing incorrect or incompletely defined objectives that don't line up with our preferences about the future, if that's the problem, then the only way we can go actually is to not build our AI systems that way. And so the way I've been thinking about it is a version of this question which actually is a bit less pessimistic. Right? It's this version. What's a mathematically defined problem such that if the AI system solves it, no matter how well it solves it, we are guaranteed to be happy with the results? Okay? And in case you're looking for a hint, right, it's not the way we're training large language models, which is to imitate human linguistic behavior. In fact, this is worse than what we were doing before, because at least with the previous generations of AI systems, we specified the objective. So, for example, all of deep reinforcement learning systems, we specify the reward function, and then we train the system to optimize it. And we make mistakes when we specify the reward function, but at least we know what it is. If you're just training AI systems to imitate human linguistic behavior, you have no idea what objectives they're actually going to end up optimizing. They will adopt many or possibly all of the goals of the people who are writing that text. So if someone is writing a sales pitch, the system will learn that it wants to sell you something. If someone is in a romantic chat room, then the system will learn to try to get the user to marry it, as happened with a New York Times journalist, where a version of GPT-4 actually goes on for 20 or 30 pages trying to convince the journalist to marry this version of GPT-4, despite his best attempts. So he said, no, I want to talk about programming languages. And it says, well, okay, my favorite programming language is Python, but no, actually, I want to talk about marriage. I think you're in love with me, and you should leave your wife, and all the rest of it, right? And just keeps coming back to the same goal because it absorbed that goal, because that goal was driving the linguistic behavior of many of the humans in the training data. And so it absorbs that goal from trying to learn how to imitate that behavior. So this approach is, as I said, worse than what we were doing before because we don't even know what goals the systems are absorbing and then pursuing. So the approach I'm working on is actually throw away this idea that systems should have predefined goals and build systems with the following principles: that their only objective, if you like, is to act in the best interests of humans, but they are explicitly uncertain about what those best interests are. So that would mean that if I gave you two possible futures of the world, the system wouldn't necessarily know which one we would prefer. And it's that uncertainty, it turns out, is what gives us control over the AI system. So this formulation actually is called an assistance game. So if you know anything about game theory, you know that it just is a decision problem involving two or more entities. And here there's at least one human and at least one machine. And the machine's payoff in the game is whatever the human payoff is. But the machine knows that it doesn't know what that payoff is. And if you want a good example of this, remember back to the last time you tried to buy the perfect birthday present for your partner. Right? So when you buy a birthday present for your partner, your payoff is exactly their payoff. Right? It's how happy they are with the present, but you don't know enough to know exactly which present is going to make them happy. And if you're like me, you keep making mistakes over and over again every year. And eventually my wife buys her own birthday present and says thank you to me. So this is a mathematically well-formed problem. And we can actually look at the solutions. We can solve small versions of this, and we can analyze generic properties of the solutions of these types of games. And we can see that if you're a machine that solves this assistance game, then you're going to be deferential to the human. In fact, the only thing that matters to you is that you're doing something that is consistent with human preferences. You're going to act very carefully, right? You don't want to mess with parts of the world where you're not sure what human preferences are. You're going to ask permission. So if you come up with a plan and parts of it might mess with the world in ways you're not sure about, then you'll ask permission and say, is it okay if I turn the oceans into sulfuric acid while I'm fixing the carbon dioxide problem? And we would say, no, we like the oceans not being sulfuric acid. Thank you, right? And ultimately, they will allow themselves to be switched off. They won't just allow themselves, they want to be switched off because they want to avoid doing anything that would violate the preferences that would cause us to want to switch them off in the first place. So these are all desirable properties, and we can show that, in fact, it's in our interest to build these types of solvers. So very quickly, let me just go through what should happen next, right? What do we need to do? And this is what governments are asking AI researchers, AI companies, philosophers, social scientists, you name it. There are two big parts of this. The first part is the research agenda. And I think this needs to be done in a way that's cooperative, both across private and public sectors and across as many countries as have interest and capability to contribute to these problems. In particular, so alignment is one. This is what I've mainly been talking about, is alignment. But containment is another approach where you design AI systems that are sufficiently restricted that they can't affect the world in harmful ways. We should build systems that are transparent and explainable instead of these giant black boxes with trillions of uninterpretable parameters. And finally, we need digital ecosystems that actually reject unsafe AI systems. You literally cannot run an unsafe system because the hardware will check the proof of safety and find it wanting and say, I'm sorry, this AI system can't be run because the proof of safety doesn't work. And then there's regulation. So we need an international body to coordinate, and of course, regulations are written at the national level, but they need to be reasonably consistent across different jurisdictions so that we can operate successfully on an international scale. So we need hard law, not just voluntary codes of conduct. We need hard law, for example, banning the impersonation of human beings. We have an absolute right to know if we're interacting with a human or a machine. We need a kill switch. So if you're deploying a system, you need to show that you can turn it off. No matter how it behaves, no matter what it does, no matter what its attempts are to prevent you from switching it off, you have an obligation to show that you can switch off this system. And we need red lines. So what does a red line mean? It means if the system crosses that line, then it's immediately removed from the market. You execute the kill switch, the system is removed from the market. So for example, if a system replicates itself, if it copies itself onto another machine, that's an immediate red line, immediate switch off, and immediate removal from the market. Breaking into other systems, advising terrorists on how to build biological weapons, and so on. So the advantage of red lines is that the onus is then on the companies, not on the public sector, on the companies, on the developers, to actually do the research so that they can prove that their systems are safe. This is what we do with nuclear power. We say, look, you want to deploy a nuclear power station? Fine. Prove to us that its failure rate is 1 in 10 million years. If you can't, tough, right? The nuclear power company can't come back and say, well, that's a really difficult standard to meet. We'll say, tough. And this is what we should say to the tech companies if they can't meet these kinds of requirements. Okay, so we have a few minutes left for questions. Thank you for your attention.
Thank you very much, Stuart. As ever, a mind-altering session, which is absolutely what you're after here. And thank you very much also for your questions as well. So, why do you think people have the power to change things for the better?
You mean, why am I not totally pessimistic?
Yeah.
Well, I think we have been lulled into this sense of impotence, actually, over the decades. Particularly in the area of technology, we've completely failed to regulate, we've completely failed to enforce rules about monopoly and antitrust behavior and all kinds of things. But there are so many other areas where we do successfully regulate. So one of my friends runs the Food Standards Agency and says, look, we have way more laws about sandwiches than we have about AI. And it's good because you don't want to buy a sandwich that's going to kill you. Right, because it's gone off or used poisonous ingredients.
It's a very low bar that you're setting for what you're eating, but yes, I get you.
Right. But we have nothing on regulating AI. So I think we want to start with the low-hanging fruit. And I think impersonation is something that I've found over and over again talking to regulators that, of course, we should have a ban on the impersonation of human beings. Of course we have that right. And I think once people wake up those muscles, those regulating muscles, then they'll realize, gosh, this is quite fun, isn't it? And they'll start regulating some more. And we don't want them to go completely over the top. But I think there is now an awareness and a willingness on the part of governments to do this. So that's the optimistic part. Pessimistic part is that there's a lot of progress happening very fast. So that large language models are mysterious, but they're quite powerful, and people are finding ways to put put them together with other kinds of AI systems to make committees out of them, all sorts of ideas on how to make them still more powerful. And that's moving very fast.
Oh my goodness, thank you so much, Stuart. We're out of time, otherwise I think we'd all quite happily stand and ask you questions for another 20 minutes at least. So everybody, it's Professor Stuart Russell. Thank you very much.
Thank you.